Hello, dear students. Welcome to our new channel BTech Mathematics 2.0. In this channel, we will discuss higher mathematics for BSc BTech students. We'll start with calculus. And in this lecture, we are going to introduce what is partial derivatives. What does the term partial derivative means? How we find the partial derivative of functions. Okay, so let's get started. First of all, what is partial derivatives? You have already studied derivatives, isn't it? Derivative of a function. That is, suppose we have y equal to f of x. It's a function in one variable. That is, or otherwise we can say that it's a function having one independent variable x. X is the independent variable here, isn't it? X is the independent variable. Depending on the value of x, we can have y. Y is the dependent variable. Okay. Therefore, in this function, we have only one independent variable x and one dependent variable y. Okay. And suppose we have to define another type of function like z is equal to f of xy. It contains two independent variables, isn't it? X and y are independent variables. Okay. And depending on the value of x and y, we can have the dependent variable z. Z depends on x and y. Okay. Suppose for the single variable function or single dependent independent variable function, we can differentiate it with respect to the independent variable. We can differentiate the function or we can differentiate the dependent variable with respect to the independent variable. Therefore, we will write dy by dx. We can write it as f dash of x. This is the derivative of the function y with respect to the variable x. But in this case, in two variable function, that is z is equal to f of xy, we cannot differentiate this z or the function f with respect to the single variable alone in this manner. Okay, so we will introduce a new notation or we introduce a new notion that is called partial derivatives. For that, if you want to differentiate this function z is equal to f of xy, we can use the partial derivatives. That is, we can differentiate the z with respect to x and with respect to y. Therefore, suppose we are differentiating z with respect to x, we will use the symbol dou z by dou x, which is equal to dou by dou x of the function f of xy. While differentiating with respect to this x, we will consider y as a constant. Okay, so we'll get this derivative and we'll denote this derivative as fx. Okay, and with respect to y, we can differentiate this function. So we'll use this notation dou z by dou y, that is equal to dou by dou z dou y of dou by dou y of f of xy. Here we are differentiating this function with respect to y, so we'll take x as a constant. Therefore, we'll get the function's derivative fy. Okay, we can have some examples. Suppose z is equal to xy plus x square plus 6y. Now we have a function like this. Okay, this is an example function. Okay, so we are going to differentiate this function with respect to x. That means that is dou z by dou x. Okay, that means dou by dou x of this function xy plus x square plus 6y. Okay, so we'll separate differentiate this separately. First of all, we have to differentiate this xy, then x square, then 6y with respect to x. While differentiating xy, we'll take y as a constant, therefore we'll take y outside, therefore we'll get a y into derivative of x with respect to x is 1 itself, isn't it? Plus x square, we have its derivative is 2x, and 6y, here 6 and y are constants according to or otherwise we are differentiating with respect to x, we will treat y as a constant, therefore this will be a constant 6y, therefore its derivative will be 0. Therefore we'll get dou z by dou x as y plus 2x. Okay, this is dou z by dou x. Okay, then we will differentiate the same function with respect to y. Dou z by dou y we will use, that is equal to dou by dou y of the function xy plus x square plus 6y. Okay, Now we can have this as differentiating with respect to y. We'll take x as a constant. We'll take x outside into derivative of y is 1 plus x square. Here there is no y, therefore it is a constant. Therefore its derivative will be 0 plus derivative of 6y. It's 6. Now its derivative will be x plus 6. This is dou z by dou y. Okay, this is the way we will differentiate a function partially with respect to x and with respect. That is, while differentiating with respect to x, we will treat x as a constant. Sorry, y as a constant. And if we are differentiating with respect to y, we will treat x as a constant. Okay, this is the first order derivative. So in this function, z is equal to f of x y. We have two first order derivatives. Dou z by dou x is a first order derivative and dou z by dou y is a first order derivative. But in this case, y equal to f of x, we have only one first order derivative, isn't it? Dy by dx is the total derivative, complete derivative. Now we are dealing with partial derivatives. Okay. So what about the second derivative of this function? Z is equal to f of xy. That is, suppose we have z is equal to f of xy. We can differentiate this function with respect to x as dou z by dou x, which is equal to fx, and dou z by dou y, which is fy. These are the first order derivatives. First order derivatives, isn't it? First order derivatives. Okay. Now, while differentiating with respect to x again, this function dou z by dou x, will get the second derivative. That is dou by dou x of dou z by dou x, which is equal to dou square z by dou x square. We can write this as a symbol, and this is equal to derivative of this fx with respect to x again. Therefore, we can write it as fxx. This is the second order derivative of z with respect to x. Okay. Similarly, we can differentiate this dou z by dou y with respect to y again. That is dou by dou y of dou z by dou y. It is equal to dou square z by dou y square. This is the second order derivative of f z with respect to y. So we'll write it as fyy. Okay, this is the second order derivative. Okay, so there is some more derivatives, isn't it? We can differentiate this first function dou z by dou x, that is fx, with respect to y again, isn't it? Therefore, we can differentiate it dou z by dou y of dou z by dou x. Now we'll write this as dou square z by dou y dou x. This is equal to, we will differentiate this fx with respect to y again, that is fxy. You'll get fxy. Okay, this is again a second order derivative. And one more thing, we can also differentiate this dou z by dou y with respect to x. That is, we can write like this, dou by dou x of dou z by dou y. Okay, now this is equal to dou square z by dou x dou y. That is, we are differentiating this fy with respect to x again. Therefore, it is fyx. Okay, all these are second order derivatives. Second order derivatives. Okay, so for therefore we have four second order derivatives, and of this, these two mixed partial derivatives, we can say this as, we can call this as mixed partial derivatives. That is dou square z by dou x dou y and dou square z by dou y dou x. We can call this as mixed partial derivatives, and these mixed partial derivatives in usual case will be equal. Okay, so we have three independent or three different second order derivatives, that is fxx, fyy, fxy or fyx, both are equal. Fxy or fyx, both are equal. These two are equal. Okay, these are the second order partial derivatives. Okay, similarly we can move on to higher order derivatives. With respect to x, we can have dou cube z by dou x cube. With respect to y, we can have dou cube z by dou y cube. Then we have dou cube z by dou x square dou y. Like that we can find more derivatives, okay, in this aspect. Okay, therefore these are the first and second order partial derivatives of a function, okay, of function in two variables. Okay, now we have an example question. Okay, find if example question, you can do this. Z is equal to x square y minus x sine xy. Okay, find dou z by dou x and dou z by dou y. So we have the function z is equal to x square y minus x sine xy. Okay, now we differentiate with respect to x, dou z by dou x. That is equal to y x square. Y is a constant. The derivative of x square is 2x. Therefore, it is 2xy minus here x into sine of xy. We have x and in this function and in this function also. Therefore, we use the product rule. Okay, minus first function into x into derivative of this one. Derivative of sine is cos of xy into derivative of xy with respect to x is y. Okay, plus we have the second function sine of xy into derivative of the first function x, it is 1. With respect to x, it is 1. Okay, now we have this function derivative as 2xy minus xy cos xy minus sin xy, isn't it? This is the first order derivative, dou z by dou x. Okay, now we'll find dou z by dou y, the other first order derivative. It is with respect to y. Therefore, while differentiating this function with respect to y, we will take x square as a constant. X square into derivative of y is 1 minus. Here also x is a constant. Therefore, we will take x outside. X into derivative of sin xy is cos xy into derivative of xy with respect to y is x, isn't it? Now this is equal to x square minus x square cos xy. Okay, x square minus x square cos xy is the first derivative, dou z by dou y. Okay, uh, now we will move to the second example, question number 2. If z is equal to log of x square plus y square, find dou z by dou x and dou z by dou y. That is, the function is z is equal to log of x square plus y square, and its first derivative with respect to x is dou z by dou x, which is equal to derivative of log is 1 by x square plus y square, okay, into derivative of x square plus y square with respect to x. Derivative of x square is 2x and derivative of y square is 0 because it's a constant. While differentiating with respect to x, we will consider x, y as a constant. Therefore, we can have 2x by x square plus y square. Okay, then we will take its another derivative with respect to y, dou z by dou y is similarly we can have 1 by x square plus y square as in the first one into derivative of x square plus y square with respect to y. X square derivative of x square is 0 and with respect to y derivative of y square is 2y, isn't it? Therefore it is 2y divided by x square plus y square. Okay, now we can this is the question where we can find its second derivative also. Okay, second derivative means dou square z by dou x square and dou square z by dou y square. What is that? Dou square z by dou x square. What will be that? This is equal to derivative of this function with respect to x. Again we will use quotient rule. X square plus y square into denominator into derivative of numerator is 2 minus numerator into derivative of denominator is 2x. Okay, divided by x square plus y square the whole square. Now we will simplify this to x square plus 2 y square minus 4x square divided by x square plus y square the whole square, isn't it? Now it is equal to, you can subtract this to y square minus 2x square. 2x square minus 4x square will be 2x square. Okay, we can have like this, x square plus y square the whole square. This is dou square z by dou x square, or otherwise we can write it as okay, We'll write like this: dou square z by dou x square. Okay, this will take it as 1. And what about the second? Uh, Dou square z by dou y square, that is equal to, we'll differentiate this function with respect to y. It is quotient rule. We will use quotient rule. Dou x square plus y square into derivative of 2y with respect to y is 2 minus 2y into derivative of x square plus y square with respect to y is 2y. Okay, divided by denominator square, x square plus y square the whole square. Now we'll write it as 2x square plus 2y square minus 4y square divided by x square plus y square the whole square. Now this is equal to 2y square minus 2x square divided by x square plus y square the whole square. Okay, this is equation number 2. Suppose, what will happen if you add these two equations? 1 plus 2 will get dou square z by dou x square plus dou square z by dou y square. This is equal to, denominator the same, we'll take the common denominator x square plus y square the whole square. Okay, and numerators are 2y square minus 2x square plus 2. Okay, there is a mistake. I have made a mistake here. It is 2x square, isn't it? 2x square minus 2y square. Okay, it is like this: 2x square, 2x square minus 2y square. Okay, therefore it is here also there is a correction. We can have it as plus 2x square minus 2y square. Okay, now we can cancel all these things in the numerator. Okay, now we'll get it as 0. That means dou square z by dou x square plus dou square z by dou y square is 0. That means this equation is a special equation which is called Laplace equation. Okay, this one is called a Laplace equation, and a function which is satisfying this Laplace equation is called harmonic function. We'll study it in complex analysis. Okay, harmonic function, just a point, just not down it. Okay, this one is a second example question, and we'll move on to the next one. Suppose we have x plus y plus z is equal to log z. Find dou z by dou x and dou z by dou y. Here the function is given as an implicit form function like this. We cannot find the value of z separately from this easily. So we'll differentiate it with respect to x. Differentiating with respect to x, we'll get 1 plus 0 plus dou z by dou x equal to derivative of log z is 1 by z into dou z by dou x. Now we have 1 plus dou z by dou x is equal to 1 by z into dou z by dou x. So we need to find dou z by dou x from this function. Okay, for that we will take this 1 by dou, or otherwise we can take 1 is equal to 1 by z minus 1 into dou z by dou x. Therefore, we can simplify this: 1 minus z by z into dou z by dou x. From this, we'll find dou z by dou x. Dou z by dou x is, we'll take its reciprocal. Okay, we will take it into this side. Therefore, this will be z by 1 minus. This is dou z by dou x. And what about this dou z by dou y? We'll differentiate with respect to y. We can have x plus y plus z is equal to log z. With respect to y, we will get 0 plus 1 plus dou z by dou y, which is equal to 1 by z into dou z by dou y. Okay, now we will write it like this: 1 is equal to 1 by z minus 1 into dou z by dou y. It is again 1 minus z by z into dou z by dou y. Okay, now we can have it as like this: dou z by dou y is equal to z by 1 minus z. Okay, this is the derivative dou z by dou x and dou z by dou y for this function. Okay, Let's stop this video here, and we'll continue this lecture in the next class. Okay, thank you. Hope you understood the questions discussed in this video. We'll see in the next video. Thank you. Bye bye.